across finance, e-commerce, social network, and currently blockchain industry. And before we get started, Michael, would you like to introduce your co-speakers?
Sure, yeah. So first of all, for people who don't know about Coinbase, we're a leading blockchain company. Mostly the business is on the crypto exchanges, but then we also have a lot of other products which we'll introduce as part of the presentation as well. Joining me for this presentation is Kathleen, who's the tech lead for our machine learning at Coinbase, and also Berkay, who's the engineering manager for the machine learning and platform team at Coinbase. So this talk is put together by three of us, and we're happy to answer any questions towards the end of the presentation. Thanks for joining us.
Okay, thank you. So we will now play the pre-recorded video, and please post your questions in the chat room. Make sure you address the question to me as well as to the speakers.
Thanks everyone for coming to our session, and KDD for inviting me to talk about machine learning at Coinbase. Our presentation topic today is build the state-of-the-art machine learning technology for the crypto economy. If you have heard about blockchain or Bitcoin, I hope that Coinbase is already a name that you're familiar with. Our vision is to provide economic freedom for every person and business. This is why we do what we do. Our mission is to create an open financial system for the world. This is what we're doing to make the vision a reality. We offer a suite of products that help people invest and utilize cryptocurrencies. The most popular one is the Coinbase app, which you can see at the top on the left-hand side. You can use the Coinbase app to buy, sell, and use cryptocurrencies. It's very easy to get started, and it has been a very popular way for people to get into the crypto economy. If you want to self-custody the cryptos that you have, you can use the second app on the left, which is Coinbase Wallet. And the one below it, USD Coin or USDC, is Coinbase stablecoin, which you can get through the Coinbase app. And it's one-to-one pegged to US dollars, so that you don't need to worry about the value of the cryptocurrency while enjoy all the technical benefits of cryptocurrency. And also we have Coinbase Earn, which you can make money through learning about cryptos. It's also available in the Coinbase app. On the right-hand side, as you can see at the top, Coinbase Pro is for advanced traders. If you trade frequently and have lots of knowledge about trading, Coinbase Pro is for you. And on the business side, we have Commerce, which is for crypto merchants to accept cryptocurrency payments, and Custody, which is a crypto storage solution for institutional customers. And lastly, we have Coinbase Venture, which is the investment arm for Coinbase to invest in crypto startups in the ecosystem. For this presentation, we will discuss 4 sections as shown on the agenda. We'll talk about data at Coinbase in general, then dive into the current landscape of machine learning at Coinbase in terms of where we use it and the sort of the business impact we have seen. Then we'll get into more details around the machine learning technology facilitating the whole machine learning development cycle. Lastly, we'll paint a picture about how we think about the future of machine learning in the blockchain space. So let's start by having a quick look at the data at Coinbase. Currently, we have more than 35 million users that have a verified email with us. And now on our platform, we have more than 20 crypto assets that you can buy, sell, send, receive, earn, and or custody. You can see some of the examples in the chart below. For example, Bitcoin is the very first one on the first row. Following it is Ethereum, the XRP, Litecoin, etc. Our services are available in more than 100 countries, which enables people worldwide to get into the crypto economy in an easy and trusted way. So the chart below shows you some of the countries as examples. So let's take a look at the type of data that we have at Coinbase. The first one, obviously, is blockchain. Blockchain is fully decentralized, and the data is publicly available. It's a huge amount of data that includes basic information about blocks, addresses, wallets, as well as on-chain transactions, and also chain-specific operations such as staking, node, etc. So the chart below, as you can see, illustrates the transactions output going to the receivers on blockchain. To be very clear, blockchain data is fully decentralized and can be accessed by anyone in the world. However, how to put them in a format that can be easily consumed and derive useful information and insights is still in very early stage and something that we have been spending a lot of time on. Second, we have our proprietary product data, which ranges from user registration, user behavior, as well as many other product engagement areas. We also use publicly available data to do tagging and clustering for entities on the blockchain. So these are all the proprietary product data that we have. In the third column, which is the external data that we acquire from vendors to augment our data, such as crypto market prices, trading volume from different exchanges, as well as very specific area like blockchain address blacklists. So overall, these are the three types of data that constitute the raw data landscape at Coinbase, which provide the foundation for any machine learning that we apply on top. So let's take a look at the landscape of machine learning at Coinbase in terms of the business areas that we have been practicing machine learning. The one area that we have built a very holistic machine learning system is fraud detection and risk management, which includes the fraud risk models at both user and transaction level, as well as a very specific account takeover model that will help us mitigate all the ATO events on the site. We also have credit risk models, which are used to determine trading limits and balance hold days. We also have a machine learning-based rule recommendation engine, which helps detect emerging fraud patterns that we can quickly implement as rules for timely detection and prevention. And the second bullet point talks about some of the progressive use cases that we have in user-facing products. For example, we have recommendation models to provide recommendations around assets that you may like. We also have a personalized news notification that we send to you on a weekly basis with the crypto news and with news tags that tell you that which crypto asset the news is about. So this is a constantly evolving areas, obviously, and we have been investing more and more time and efforts as machine learning is increasingly become a core part of our product experience. And lastly, the third one, which we have some early attempts to apply machine learning on the blockchain data, such as blockchain entities and the tagging, clustering associated with it, so that we can identify the entities on the blockchain, such as exchanges, mixers, miners, etc. It's still very, very early days, but we have seen some very full use cases already, and we believe that this is just the beginning of a very long runway for machine learning on blockchain as blockchain increases its adoption. So next, let's take a look at the impact of machine learning at Coinbase. We can break it down to a few areas. Like I mentioned, we build very holistic machine learning systems in the fraud detection and risk management area, and we have seen a pretty promising impact coming out of it as well. So from year 2018 to 2019, we have seen a massive reduction on fraud loss because of the machine learning models that we built. The fraud rate reduction is close to 50% on a year-over-year basis, which not only improves Coinbase profit margins significantly, but also more importantly, it creates a better user experience and a safer environment for people to get into the crypto world, which sometimes can be thought as the Wild West. Meanwhile, we started to enable more and more new business opportunities as well. The example we use here is we build models to let people have higher limits and they can trade more quickly so that they don't miss any opportunities in the crypto trading world. Lastly, we believe that everything eventually should contribute to create a better user experience. And this is an area that we have been increasing our investment a lot over time. So this includes things like intelligence and automated insights, which help our users to get timely help for what they need. And the right-hand side provided some examples for a asset signals that we created in our app to help facilitate our users to trade cryptos. And this is a snapshot from the news coverage from TechCrunch. So the following sections of this presentation will focus on the machine learning technology and systems behind the scene that help us achieve all this impact that we have talked about. So let's start with the development cycle of machine learning. We believe that there are three critical steps to make machine learning work. First, we focus on the problem that we want to solve and define how we can solve it using what target metric. Then we prototype the model with training data, analyze the impact from the model, and iterate to get to a good model performance in backtesting. At this stage, it's very important to iterate quickly and know that if we are getting better results, better model performance. And from there, we work on putting the model into production environment and partner with product and engineering teams to ensure that it works as expected. Then we start to roll out the model with clearly defined experiments that are created to guide us on the ranking process. So only when we see statistically significant causal impact in target metric and no negative impact to the guardrail metrics that we run to model to 100% of our users. Then we start another development cycle to improve the model again. So with this in mind, what are the machine learning technologies that have been used in enabling such model development cycle? So we categorize them into four major components. First is our machine learning platform, Nostradamus, which is responsible for model serving and coordinating all the production costs. Second is the feature store, which is a standalone self-serve framework responsible for feature management, computation, and service. And the third is EasyML. It's an AutoML framework that enables machine learning engineers to quickly build high-performance models. And lastly, OCIFER, Coinbase Experimentation and Metrics platform, which is responsible for model performance measurement and evaluation. We'll go through all four of them one by one in the following slides. So first, Nostradamus, our machine learning platform, is the core technology that we have to deploy training jobs, notebooks, and endpoints, as well as coordinate production costs. And Nostradamus serving is responsible for all model serving requests with metrics and events monitoring for all the models to ensure great reliability. Nostradamus clients make it very easy for the product and engineering teams to integrate machine learning services by providing an abstract layer for all other services. And we have enabled support in Ruby and Python. And we're expanding that to all other production languages as we speak as well. Lastly, Nostradamus also has a command line tool in case that machine learning engineers prefer to use it. So here is the architecture chart for Nostradamus. As you can see that Nostradamus core sits here that coordinates a lot of the production costs. And it has a UI with Nostradamus logo on it. So it coordinates the notebooks, training jobs, also creates a model endpoint. And the Nostradamus serving, in turn, takes a request from client side and then use the model endpoint to serve production. And you can see here we also have events and metric monitoring in place to ensure that the system is working properly. So next, let's talk about the feature store. It's very early still, but we have seen very encouraging results from the feature store. And before feature store, we serve models where feature vectors customized and essentially built in a production system by our production engineering teams. However, not only it requires a lot of separate efforts from product engineering teams, but also it's very error prone and very hard to keep in sync with the features we use in offline training. So that motivated us to create the feature store, through which not only that we can train and serve models with consistent sets of features, but also we can decouple really the engineering efforts on machine learning with the rest of the production system, so that we can quickly iterate on the machine learning models without dependencies. While we were building the feature store, we also designed it to be self-served, so that our machine learning engineers can later just add, modify, delete features very easily. So the core responsibility for the feature store is obviously the real-time feature piece. And we made it possible for both training and serving with streaming process technology Apache Flink, which ingests events data, transform the data, calculate real-time features, and write features into low latency key-value stores for serving with high performance. And within the Nostradamus and the feature store, we also centralize the SQL logics so that the feature store can enable us to have essentially consistent logic everywhere, whether it's batch processing or streaming data. We call it batch streaming unification. So we always have consistent feature generation logics for both training and serving. Lastly, the feature store is designed to scale with Flink tables and SQL APIs to define jobs in a declarative way. So now all the new models that we built are using the feature store now, and we have seen significant improvement in performance and high efficiency in model iteration and maintenance. We're also in the process of essentially migrating all the old models that were not built on feature store to use feature store as well. So this is the architecture chart for the feature store. As you can see that we use Kinesis streams to send the data from many sources that we collected data from. And for both the offline training, which is at the bottom, as well as the online serving piece. And in the middle, you have all the Flink jobs, essentially that define the feature logics in a consistent way for both training and serving, so that model machine learning engineers can build a model using all offline features, while the Nostradamus serving can use all the online features, while they're all in consistent manner. So to start, I want to spend some time to introduce EasyML, which is our AutoML framework that we use internally to build and improve most of our machine learning models. As its name speaks, EasyML is designed to be very easy and fast to use. It has the one base model for our approach, which unifies the training and serving workflows into one Python package, and provides better testing and performance while enabling higher explainability. In doing this, oftentimes you only need to write less than 20 lines of code to build a new model. You can even build a model with just a piece of SQL code in the UI, as you can see in the next slide. Lastly, we centralize our model building workflows in EasyML, which gives us the benefits that any improvement to EasyML will automatically propagate all the improvements to all the models using EasyML, which basically achieve what we call model enhancement at scale. So as I mentioned, there are two ways to use EasyML. You can see them on the left. So on the top, you have the UI, where you can copy paste a piece of SQL code following the guidance to define the target variables and all the features that you want to use. Then just click a button, and you'll see the model built in the backend. Alternatively, you can also import the EasyML module into your Python code and create a model very easily with less than 20 lines of code, as an example here. The charts on the left are model performance metrics once the model is built in EasyML. As shown that you have the feature importance ranked from strongest to weakest. You also have the AUC curve chart on the right-hand side on the top. And the bottom left is model summary metrics that you have all the key performance metrics listed out for you. And the bottom right is a chart to show you that for a particular feature with different values, what the model output you get. Of course, like what's shown here is just part of all the model output that you can get from EasyML. And you can change the script to customize many ways as well. As EasyML continues to improve and develop its core technology, we recently also added an improvement, which is what we call seek to win, meaning to use sequence data to win. This enabled machine learning engineers to create deep learning models based on a sequence of events data. Before seek to win, all EasyML models were built on structured tabular data, but we were missing out on using all the events data from both front-end and back-end that can tell us more accurately about user intent. We also used the state-of-the-art deep learning model based on the transformer architecture to get the best performance for the events data. So another great thing about events data, obviously, is that it's agnostic about business domains. So seek to win can be leveraged across all the different business problems by simply changing the objective function. This goes back to our earlier point about the model enhancement at scale, as we just talked about. And the latest enhancement in EasyML is what we call EasyBlend. Essentially, it's a framework to get the best model performance in combining models with distinct architecture and features in a very efficient way. So the bottom two charts illustrate how this works. The left chart shows that we split the training data set into training data for all the models, and then the training data for the blended model, which is essentially the model that is built on top of all the models. And both of them use the same validation data set so that we can compare across different models in a fair way. So first, we train all the models, which can have distinct model algorithm, for example, logistic regression versus deep learning versus XGBoost. And they can have completely different features. For example, some of them are using tabular data, some of them are using events data. And once we have all the models built, then we build a blended model on top of all of them by just taking all the individual model output as training data and validate the blended model score with the same validation data set to prove that the model performance is actually better with the blended model. We have tried this approach quite a few times in production, and it has been giving us really positive results. And sometimes that the improvement can be very substantial. So the last component I want to talk about today is OCIFER, the experimentation and metrics platform at Coinbase. We will not get into the details about how OCIFER was built, how it works, as it's not focused for the experimentation. And also we'll publish a blog with more details later in Q4 to talk about OCIFER as a separate topic. Please stay tuned. So what we want to focus on today is how we measure and evaluate model performance when we roll out the model. So we have a very strictly managed process in experimentation. Every model has a target metric that we optimize for, as well as a set of guardrail metrics that we use to ensure we don't accidentally impact certain metrics. And typically these metrics are company-level core metrics. We ramp up the model rollout percentage to users following what the experiment results tell us. And with a good practice like this, we can clearly communicate the impact for model performance to the team and to the leadership team in the company so that everyone has full confidence in machine learning initiatives that we have. Of course, we also use experimentation for almost all the product features that we roll out, and machine learning is just one type of experiments that we run. But it has been helping us immensely and help us iterate quickly in both ramping up and ramping down our machine learning models in a very responsible manner. So on the right-hand side, as you can see, this is the UI for CIFER, and this is one of the models that we built in December 2019. You have a bunch of metrics that you create and monitor, and it tracks the percentage changes, and with the p-value, with their MDE, and you have a rump chart to show that how many users the model has been rolling out to. So at the end, I want to share some very cool stats of machine learning at Coinbase, at least that I think, because we have come a very long way since we started our machine learning efforts just a few years ago. So Nostradamus, as I talk about our core machine learning platform, now we have a performance typically at 4 nines in terms of response success rate and uptime, which is a very high bar, and we like to continue to maintain going forward. The training time of the slowest model that we have has been brought down from 24 hours in the past now to only 1 hour at most. So it's more than 20x improvement just in iteration speed itself. And the largest model that we have served so far is 40 gigabytes, for which that we actually have to build quite a few workarounds to enable the model serving. The time to production, essentially when you have an endpoint for machine learning model to when the machine learning can be actually implemented in production and serve our users, it used to take 1 month for us to do that. Now that we reduce it down to 1 day, and that's close to 30x improvement. Not only that, but also that we make the code reuse increase from almost 0 to now that everything but model logic. So it saves a lot of time for machine learning engineers to iterate on the models to get to better performance. And lastly, when we build it out, obviously, we want our tech stack to be mostly portable whenever possible, so that we can always make it work for different type of production environment. So the bottom right shows some of the metrics and advanced monitoring that we have for Nostradamus. This is the reliability metric that we just talked about. This is how many predictions the model makes, and essentially the errors out of all these predictions the model served. So as you can see, that's in a very healthy stage. So I'd like to end this presentation by providing a future projection of machine learning at Coinbase and more broadly for the blockchain industry. We see 3 broader directions for our machine learning strategy. Number 1, enable universal personalization in the whole crypto user experience. This is similar to all the consumer product technology we are seeing today. Essentially, machine learning should be empowering user experience everywhere when possible. In Coinbase's case, we oftentimes introduce users from the fiat world to the crypto world for the first time. How we can facilitate that with machine learning to make every step of the experience easy and enjoyable will be the key in how we accelerate the adoption of crypto and blockchain. We also want to leverage a lot of the existing technology in doing this as well, because they are out there, they're available, and we actually have a lot to learn and adopt at Coinbase here. The second direction that we are seeing is the so-called native machine learning with blockchain data. Blockchain data is huge and very complex, as I mentioned, and it evolves very quickly all the time as innovations in blockchain technology are happening at light speed. So for now, we are still thinking blockchain data as a complement of all other data that we have, and use it sometimes as optional. We believe that, though, in the future, machine learning should be just using blockchain data as default, if not the major part of the data that we consider. This transition means that we need not only to continue to improve the quality and process of using blockchain data, but also we need to change our mindset, essentially to think blockchain data is essential. An analogy that maybe we can use is in 1995, using internet data is oftentimes not even thought about, or like we use internet data as a complement of local data in your laptop. Now, if you think about data, it's essentially all available on internet. And it's basically how you think about data and where you get the data. So we believe that will gradually happening with blockchain and blockchain data as well. The last direction we see is that eventually machine learning will be decentralized on blockchain, just like the blockchain itself. Blockchain is essentially a decentralized database. With this decentralized nature and the data already available in every node that it's running on, we can see how machine learning can be enabled on top of it in a decentralized manner as well. Imagine that in the future, all the machine learning algorithms will be running locally on the blockchain. So everyone has not only personalized results, but also personalized algorithms in a decentralized way. We're looking forward to seeing that happen in the years to come. With this, I want to conclude my presentation today. Thanks everyone for joining the Machine Learning at Coinbase session at KDD 2020, and I'm happy to take questions.
Okay, thanks a lot. And at this moment, I'm turning on the chat room, and so you can post your questions on chat, and you can also unmute yourself. And let me pose the first question. This is from Non-Pol. For the feature store, are all features available for all DSMLE, or is there access control? If there is, can he go into a bit more detail about how to approach scalable access controls, especially as the number of features in the feature store increases significantly?
So maybe thanks for the question. And let me address it maybe on the higher level, so how we think about data semantics and data access control, data governance, broadly speaking at Coinbase, right? Because we are a fintech company, right? Obviously that data privacy and data security is super critical for us. So when we address these type of questions, we always think at the holistic level, how do we have a proper control in place? And the way that we do it at the Coinbase is we recently actually published a blog. Feel free to check it out. That's blog.coinbase.com. In terms of we actually have a consistent data semantic layer for all data systems at Coinbase. This including all the features that we use for machine learning models, but this also includes all the other metrics or numbers or data that we use both internally at Coinbase and externally, right, with our users, our products. So with that data semantic layer, consistent data semantic layer across the board, so we know who's the owner of each metrics or features, and then how we can apply appropriate access control for them to allow access to whom. Right, so that's the broader sort of thing.